All right. Thank you to our speakers for setting the stage. We're going to invite them to come on up, and we've got about a solid hour here for a panel presentation. I'm going to turn things over to Brett to lead in PDH code. While these guys are getting set up here.
So good evening. My name is Brett Harris. I work with CRESO. And as we were talking about different hot topic sessions earlier in the year, we kind of we're thinking about, where as an industry have we stubbed our toe? What can we do that helps us move forward? So thank you all the speakers. I appreciate this. So as we have this roundtable, I want to keep everybody in mind that this is not necessarily a wine session about 1L. We've heard enough about that in some ways. But what we want to do is try to ask questions, learn from one another here about, how do we adapt to changes more quickly? And while we've been talking about cements here, some of these same concepts can go towards changing aggregate sources in different regions. As an industry, we need to get better at change and be able to adapt and change faster. So through communication, different types of testing and working together is a way to achieve that. A lot of these speakers up here have some experience with that. It's a great resource to start from. And I'm going to be moving this mic around for people. So just raise your hand, introduce yourself, and we'll go from there.
I'm Rachel Detweiler from Baton Consulting Engineers in Minneapolis. And several of the speakers had mentioned the importance of doing, whether you call it trial batching or mock-up or something else. And I would heartily agree with that. But I would add that at least in places like where I come from, where there's a huge difference between winter and summer, it would be very, very helpful to do some of those tests at the extremes of temperature that you're likely to encounter, because there is, if you're doing it in the summer and it works fine, like with your slag cement and your high glass content and all that, then how is it going to behave in the wintertime? It would be really nice not to be surprised by that. And you might also, as we sometimes do, change the mixture from winter to summer. In other words, if you are trying to lower the carbon footprint of your concrete for the whole project, you might get more out of that in the summer and less in the winter, but it averages out so that you can still maintain your timelines and you can still do everything that you need to do, but you're not fighting it so much.
If I may, our trial batching for those mixes that I showed in the projects that were successful, our first trial batch was on February 14th outside, because we knew we were going to have a problem because of the high replacement. We wanted to see how it behaved in that extreme. So absolutely spot on, especially you're very familiar with. Your winter's a little bit longer than what we have here, but absolutely.
Anybody else want to?
I was just gonna say, I love the suggestion, change the mix design. Like that's really key. Is the mix design has to change. There's too many engineers that want a submittal, and that's it. That's what was approved. If you have to go back and do a submittal, just change the mix design as the seasons change.
The other day I was talking to a finisher, and they weren't dealing with anything complex like this, but blended cements, just pretty much plain 1L concrete. And the gentleman was saying, well, we had all this bleed water on one day, and the very next day we poured the same mix and had no bleed water, couldn't finish it. So I started asking a little bit more. And he was like, we did everything exactly the same. Well, it turns out the first day he was pouring on plastic in a garage. The next day was pouring out in the open on dirt. And he expected everything to be the same, and he did nothing different to compensate. So, temperature, same thing. It's going to be different temperatures. We have to adapt and expect change and do something different for that. I think it was, you were next.
Thank you. Siva with Siva Corrosion. And one other thing I think Jim mentioned, and you mentioned as well, that it's not the problem of one, it's all of us as an industry work together. given that we all talked about the finishing, how we have to do that, what the number of passes and whatnot. What would you say when somebody's using a bid well to finish a deck and we got the same issue problems?
We've seen very little issues with the bid well, where on a bridge deck, if we have scaling anywhere, it's under gutter lines where it's been worked by hand. So we really don't see it with the bid well. It's DOT projects is tightly controlled. Heavy testing going in like that. The bid well closes it up, and then the drag behind it does the rest. But I think our DOTs have learned, and I wish would be passed it on to the rest of the industry, that the less you can do, the better it is. And I think that's why we don't really see the issues behind the bid well.
Well, it's been a long day, so it's probably trying to be provocative at the risk of job security, but I'll probably bring up a couple of things. I'm Colin Lobo with the National Ready Mix Concrete Association. So basically, yes, we do support the cement industry's roadmap to low carbon. And yes, paving contractors have one mix design, and that's what they do all day, every day. Precast probably does something similar. Ready mix concrete guys probably have about 50 different mix designs that they have to do every day for different applications. Okay, when you have a reduced carbon content of blended cements, I mean, there's a presumption that the ready mix concrete industry cannot reduce their carbon content by themselves. We've been doing it for many years. I mean, maybe for economic reasons and not for performance or carbon reasons, but yes, it's been done for many years. When we have a blended cement with lower clinker content, we have three problems. Okay, one is we probably increase the cement content to achieve the strength, which defeats the purpose of having low carbon concrete. Secondly, we have a challenge with flexibility for different applications that we need for foundations or pre-stressed or post-tensioned or formwork removal or whatever. We have reduced flexibility to achieving those goals. And then, the other thing is eventually not everybody is all about low carbon, and we are silo constrained. But if we have the flexibility to have more ability to use more products, we can deliver that. And not everybody can do it, I agree. But there are progressive producers that want the flexibility to have more silos, to do more what they can do for the industry. So maybe it's not a question that can be answered, but I just want to bring it up.
Did anybody want to respond to that?
I don't argue with it. Anything you said. I think everything you said was correct. I do think that there are some strategies you can use, and I think they do them in Europe now, where they'll have like a straight cement and then a blended cement. And with the straight cement, they can use things like early age strength gain. They can do they're a little bit more flexibility in that. But I agree with you, Colin. I think a progressive ready mix supplier, as we've seen, can do amazing, amazing, amazing things. There's just not enough of them.
Change is hard, and they don't want to change. It's okay. Some of us have to, though, and Colin, you're spot on. That's why we're here. Change is hard, and some of us have to push it forward. Others will follow. They will.
Okay, excuse me. Nick Carino, consultant. Tyler, a question about your finishing device.
Yes.
Do you measure the force during this process?
No, we don't measure a force. We just try to keep a constant speed as we go forward and back.
Okay. Have you considered doing more fundamental measurements, like rheometer type?
I've done plenty of rheometers. The goal here today was to be practical and be things that you could buy at Lowe's.
Yeah, but practical in science. Sometimes.
So
what affects finishability?
Eric, do you want to talk about rheometer? Because you're the person I know the most about.
I mean, I think the thing for me, the finishability, it's so many different things. When people say it's the finishability, is it related to the setting time? Is it related to the stickiness and the rheology of the paste? Is it related to what stage of finishing? Is it when they're doing the hard traveling? So there's not one factor. So I agree that, certainly with the rheometer, you can measure the tribology, you can see how this finishes, but that's one piece of it. And I think there's no test that puts it all together. And I've not found a way better than doing a mock-up that's going to get at all of the different stages of finishing.
Okay, another comment. I agree with Rachel on her suggestion to do tests at other than standard temperatures. That's vital. If we want to use things like the maturity method, we have to know how these new blended cements will respond to temperature. For the Miller and Long presentation, I was curious, what do you use for in-place strength at early ages for formwork removal?
It really depends. So if an owner design team will allow us, we would use we use maturity meters. We've done both, but typically for us, probably 80% of the time, we're still good old antiquated field cured cylinders, because the jurisdiction drives us to utilize that. So, but would love to use more maturity meters to make sure we ensure our success. Great question.
Yep. Yeah. Good question. Yeah, so we're doing some work for ASCC now, where we are getting 20 different cements from around the United States. Some with 1L, some from the same clinker, 1, 2, 1L, and we're not running it at 2 inches slump. That's just what they chose to do. Ours is more at about 5 or 6 inch slump, okay, and we see the same type of data. We see a disparity in what's going on. Obviously, as you make your slump go up, it gets easier to finish. But we still see a difference. And I think we brought it up again and again and again. It's this comparative difference that matters. And I agree, Nick, that we're not doing everything we could, but we need to do something simple, because that's how helps people move ahead. And I love rheometers. I think they're great. I use a rheometer. On every one of those mixes, I use a rheometer. I've got tons of rheometer data. But I'll tell you, nothing correlates as well as just seeing how it goes through the concrete. Yeah, good idea. That's why it's great to come to ACI and get some ideas thrown on you. But right, totally agree, brother. Right. Yeah. It's just something that people have found to be useful, and you probably don't need it, because you can probably feel it and taste it like me, and then you just know how it's going to go, right? I was just curious if you saw the same disparities at the higher rates. We did. Are you using the same water content or just the same slump? Same slump. Water reducer dosage is different, but they're not that far different, but they're different.
Karthik Kobla with Welcome Materials. Some of the newer materials we're seeing, like the ones we're discussing, seeing less bleeds because of the more fines, right? And so it kind of tends to have more potential for plastic cracking, right? So what do you think is the best solution in terms of, is it like simple evaporation retardants? Is that will that solve the problem? Can you address it for all kinds of slabs, laser-creed, large floor slab patterns, or evaporation retardants are all similar? Or they like, do you have like a control, like, is there a standard, like an ASTM, like where you say all evaporation retardants are qualified? So how do you address that issue? Because we keep hearing about that a lot from our customers.
It sounds like you're saying that how do you help people deal with the reduced bleed and the increased plastic shrinkage? So I'd like to hear what other people have to say, but I'll just say shortly. We do a test that I didn't have time to talk about. That's very simple. You put like a box fan that blows over the top. You have a heating lamp that heats down. You put the sample on a scale, right? And you measure the mass that goes off over time. I've got a YouTube video about it. You can check it out, right? But it's a very, very simple way to compare, and you will see instantly when it stops bleeding, because you'll get a certain evaporation rate with the scale. As soon as it stops bleeding, it will stop and start to go down. And my answer, and I'd love to hear everybody else's answer to this, okay? But my answer on the plastic shrinkage cracking is, if you use with the right microsynthetic fiber, you can use 1 or a half a pound, and it kills plastic shrinkage cracking. Like, kills it dead. I got a lot of data if you want to talk about it sometime, okay? But there's other technologies out there as well, but that is the one that I've said in the state of Oklahoma that we should use in way more. And I've said that ready-mix suppliers should just basically advise, you need to use this or we're not responsible. Does that make sense, what I'm saying? You can do what you want with it, but literally say, these are the ingredients for plastic shrinkage cracking. We suggest you use this fiber at this dosage, or we're not responsible. I don't know if that's going to fly in court or not, but that's what I think. I think there needs to be that push to stop these issues. So I'm going to be quiet because you guys do this more than I do.
It's a tough sell, because that would solve the problem, but at 35,000 cubic yards, that's a pretty expensive sell. It is. So, if the job, if the project requires it, that's great. That's fantastic. But I don't know. It's the age-old problem, and we attempt to exclude it on our projects. It's plastic shrinkage. Concrete's going to crack, but when you get a nice 1/8-inch gap over a third span of a parking garage, they don't want to hear that. They want you to route the cracks and fix them. So we tend to bless our slabs a little more. So when that increases more, we go to a finishing aid, and that helps us a little bit. It doesn't eliminate it, though. It's a wonderful question. I wish there was a solution that wasn't really expensive to solve it, but it's hard.
How do the fibers help with plastic shrinkage cracking? Well, the fibers do a good job. They're really low modulus, and they help hold the concrete together when it tries to crack. I also think they also help water move from in the innards of the concrete to the top. That's my opinion. Okay, I'd love to do more research on that. Stay tuned.
Also, we've strongly encouraged in finished classes the use of a surface evaporation retarder. Almost kind of switch the conversation with the finishers. Don't tell me why you don't. Don't tell me why I need to use it. Tell me why you don't need to use it. You got a number on your video where we say like 60% or 50% relative humidity. Yeah, we say the same thing. And what we do is, in the finisher classes in a classroom, most days in the Northeast, the humidity starts out a little higher and the day drops, the day goes on. So I say right after you're done bull floating, group decision, surface evaporation retarder, yes or no, and why. So we have that discussion here on that. I've got good finishers telling me I use it every day. And I cannot give you a reason why you should not use it every day. It does not slow you down. It keeps that moisture in, compensates for that lack of bleed water. So we've been promoting the use of it, and it's a much less than fiber.
Yeah, and I would add on Karthik, we heard the same feedback. I think a lot of people have said this on bleeding. So we measured a bunch of 1-2 cements for bleeding, and there's a big difference between different 1-2 cements on bleeding, because we're trying to say, okay, what is the target? What do we define as success? We need a blended cement that acts like a 1-2 cement. and there's such a wide range. So I think it really comes down to what Colin actually said before, is that the concrete producer can make a lot of these changes and achieving the mixes. And so there's certainly fly ash has a profound effect, a much bigger effect on bleeding we found than cement. The admixtures, retarders have a big impact, and then of course plastic shrinkage cracking, and it's plastic fibers are a great solution for plastic shrinkage cracking. So I think it's really a concrete, certainly. There's an array of options to the concrete producer and the contractor to address it, to address the difference in bleeding.
Bin Tiem from Quick Creek. Talks, great discussion, but I want to echo, what Colin's comments about. We love, porcelain. We like to, reduce the carbon. All those are great idea. But who should be doing that? Actually, the ready-mix concrete, they have been doing that for years, right? Fly ash has been used, slag has been used, okay? So the flexibility is very, very important. So when we talk about, why in the USA, we have so much hurdle when we promote type 1L. In Europe, they've been using the limestone, cement for years because they always have the type 1-2 available. They have that availability. So in USA, we want to talk, can we still, the challenging to the cement industry is, can you still supply type 1-2? Then you let ready-mix, let us to do the mix design. We can do those. Otherwise, we are kidnapped, And for some certain products, okay, we have no choice but type 1L. And for certain application, for high early strength, we have no choice. For the flow, for the industrial grout, we have to add more flow agent. So that's not a good choice. So I want to say, we love all those changes. It doesn't mean we don't want changes. I like the idea, type 1L is a wake-up call. That's great. However, the cement industry need to give people the choice. Right now, 75% of the industry, switch to type 1L. Type 1-2 is just not available. For certain application, we need type 1-2.
How you doing? Brian with Belfast. I was probably more for Jim. With the new mixes, have you seen more finishers needed, more equipment and material being adjusted during those pours with the different mixtures? And then on top of that, you talked about finishing aids. It seems like everybody came out with 1L finishing aids probably over the last year, a couple of years. Did you use those as well, or did you have to work to develop new finishing aids for the adjusted mixes?
Great question. Boy, we have matured and learned a lot over the years. In 2020, we didn't know what we were doing a lot of the time, I'm being honest. We would tweak the mixes with admixtures, and we didn't understand how quickly we would hit initial set. We didn't know that a finishing aid even existed, or an evaporation retarder. We didn't know. So we would start blessing things, and we'd create plastic shrinkage cracking. So that last parking garage that I showed on my slides, we have since slab on grade of that garage been using a finishing aid and have had rousing success and improved. Now, those mixes were very gooey because they were 50% replacement. So we had to do a lot of tweaking initially, but I think all of us have echoed this. There are so many variables involved in that process. We had to keep trying one each day. It was 95 degrees with low humidity. The slabs were just taking off in a heartbeat. And the one thing that really helped plastic shrinkage the most was a finishing aid. This is just in the last year we've learned that to be very helpful. So it's a trial and error thing, unfortunately, for us. And these guys have all had great points on all that. Having finishers that are stubborn and they've done things one way for the last 50 years, it's really hard to teach that old dog a new trick, but we've got to try.
I have one other question. For the blended cements, I know some people are blending it at the ready mix plant. Are we seeing that more go towards the cement producer pre-mixing it and sending it out that way, or still continue mixing that at the ready mix plant?
Yeah, I would say, I mean, you see the trend to more blended cements, but that doesn't mean you cannot continue to add SCM at the concrete plant. So this is not a either or choice. And the data that I showed before, continue to add the 20% fly ash on top of that blended cement that has pozzolan to ultimately drive higher clinker substitution rates, lower CO2, higher durability. So I would push back on the concept that there's less flexibility for the ready mix producer when using a blended cement. There's still a lot of levers that they have to make adjustments to the mix and get what the contractor ultimately needs.
Hi, Josh, AG. Work for Wilhelm, a contractor. I just want to say I feel your pain. We've dealt with some of those 50% mixes in cold weather, and it's tough. So I'm there with you, man. But going back to the plastic shrinkage, we've found on mixes we have the availability to adjust a little bit, actually accelerate the mix even in hot weather. To kind of close the window for potential of the shrinkage cracks, let the jelly get hard to catch up with the top in your jelly donut, right? It's all curing together, getting hard together. So we found that accelerating it, as weird as it sounds, actually helps too. But I have a question. With these new blended cements and the potential for more slag and other things in it, what does that do with pumpability? Because, slag is sticky and fly ash pumps great and all that. When it comes pre-blended, what's that do to me and my pumps?
There's a lot there. Paste factor for us is significant. If we're trying to pump a 3,000 PSI mix, whether it's blended or not, and it's bony, we've got a lot of rock and very little sand and paste in that mix, we're going to run the pressure of the pump way up. And when we, the garage example I just referred to, it doesn't matter how high or how far we're pumping. It could be 10 feet away. With it being so gooey and we have so many admixtures in that blend, we run high significant pressures. We haven't solved that problem yet. There's no admixture we've added. We've tried, but the pressures are still high. It's different. It's a different behaving mixture. We can't get it back to where it was, straight type 1, type 2, or type 1-2 with 650 pounds and stone and sand and water. It's just not going to be that way anymore. We've got to be really careful as you're running really high pressures. The further we pump it, the higher we pump it, and the higher the cementitious in that mix. No good answer for you. I live it. We have 6 pumps of our own, and we tax them every day right now.
There are a couple things. One, you talk about testing mixes. We've been involved with some projects we use, like it's called the sliper. But there are some rheology modifiers that, while yes, pressures might be up, can significantly reduce those pump pressures.
I like to talk about his increase the use of accelerator. 100% agree, and I've learned that from the finishers. And I had a couple guys come up to me. They didn't want to do it in front of the room quietly in a break. Hey, we use 2% non-chloride every day if it's hot out. What do you think? And I said, how's it working out for you? And so we're encouraged the finishers, when they've got replacements in their mix, work with their producer, kind of push your accelerator use, and everybody's got to get past the fact that it's a bad thing. No, it's actually really needed and really improved.
Just got a really tight window there to get it down and make sure it's where you need it to be. But yes, it can work.
That's why you want to use a trial batch, not a mock-up.
Certified contractor.
Jim, I've got a question too. Have you attempted that process with an outside producer, and what did that look like, and how did that communication channel change?
Tell me more, Brett. What do you mean with an outside producer?
So,
What do you
I mean, well, with some of these projects, you were using your own plant.
yes, yeah.
Okay. So have there been projects where you've gone down this path of higher pozzolans and tri-blends with an outside producer? And what did that communication channel look like differently? What things did you learn that, we need, internally it's all kind of fluid because we're all on the same page. What things did you have to do
you're too kind.
differently in handling that in communication?
Great question. We have recently, so we have a project just now, data centers are the liveliest and most fruit-bearing type of project in this region right now. And Amazon is the leader, and the others are right behind them with very sustainable mixes. And you have to use a tri-blend to get to their sustainability goals. So because of our experiences, we were able to leverage that to talk to a ready mix producer in the region and say, this can be done. We'll help you get there. We did a series of trial batches with them, and it was a cost of entry admission to doing the work with us. This is going to be difficult. You're not going to be able to go to your tablet of 50 mix designs. We're going to create these together, and we're going to make sure that they're plastic enough we can pump them and finish them together. And we're probably going to waste a little bit of concrete at the beginning of these projects because we don't have any other option here. We can't just say, oh, sure, we'll do it, and then not, because we won't get the next one. So we had to leverage the experiences that I'm talking about here. Now, fly ash and GGP, they don't behave quite the same, but they're similar. So we can take those mixed constituents and leverage those to help the ready mix producer not have to guess as much. Still lots of trial and error. We mess up as much as we're successful, or more so, but that's how we get there. But the material has to be available. That's where it gets challenging. And in the middle of Southern Virginia, it's not always available. Yep. That's right. Yeah. True. It is, but yeah, it's not a small runway. It is not. You can't take the project at 30 days and say, sure, I'll rip out EPDs, and we need a year. We need data, right? The transportation to the middle of Virginia is very different than to the middle of Baltimore. So those EPDs aren't available. We can take us, educated guesses at that, provide that data, and now have performance statistics that we could leverage. It's not going to be exact, but that's all we can do. And the competition is either going to do that or promise it. So you have to say, give us a little bit of help here, give us the time, and then we'll provide the old project data to say, here, we have experience with it. So we can't do it in 30 days, but maybe in 6 months, once we have established, it's tough. Right. It's hard. Yeah. And you can't promise that because it's just not, it's impossible. You can't run it. You can't turn it around. Yeah. Yeah. That you have to take comparables, and you have to take, let's say the delivery range is somewhere between 25 and 50 miles to get the material. So you can run the EPDs, you can run a comparable, the geology in this region is reasonable. What you get in Northern Virginia is reasonably approximate to what you get in southeastern Pennsylvania, things like that. So we just have to show those comps of what's available so that they can run with it. Like with the core and those garage deck mixes that we had, for example, that was a 6-month process of rejection. Please give me, let us explain. And the dialogue has to be open on both ends. It cannot be sorry, rejected. Someone will figure it out. So you have to have that openness. They have to have the openness to be able to allow you the time to produce it.
So I thought I'll just do a little different switch to this. While the topic is blended cements, the ultimate goal is low carbon concrete, correct? And so when we look at low carbon concrete, we have a historical trend that we are over designing our mixes, let's just for strength, by 35% or more. Okay, we've consistently seen this. And so it's very hard to say, how do we get to low carbon concrete? And the reasons are simple. We have specifications that are prescriptive and unreasonable. And we have to evolve to say, can engineers change their mindset to remove some of these prescriptive? And they're very simple. There are minimum cement contents, even though none of the ACI documents have a minimum cement content. We see 50% of the specifications out there have a minimum cement content, and that's private. Maybe 100% of the DOTs have a minimum cement content. So why do we have that? And it's unreasonable because you have adverse performance implications by a minimum cement content. You have very conservative water cement ratios, and if you know the basic math of calculating a water cement ratio, you start with water, and when you divide by the water cement ratio, you elevate your cement content. So, okay, that's one. Thirdly, we have the problem of testing, okay? And I don't want to go there because we can stay until midnight. So these are all the reasons why we have a much higher delivered concrete strength. Forget about water addition on all the job site and all that stuff. But if the eventual goal is to get low carbon concrete, we are very constrained by these effects, okay? And blended cements is one part of the solution, but there's a much bigger problem out there.
You and I have talked about water cement ratios. Yet below grade structures in this region at a 0.40, you're running a 6,000 or 7,000 PSI foundation below grade. And to get low carbon concrete from that, you're fighting a losing battle by the time you hit grade because of ACI requirements. Very true.
So, and I think sometimes that's also education with engineers. So
absolutely,
I've been involved in projects where a water cement ratio was specified. So working with the contractor, went back to the engineers and said, what can we do if we, all of a sudden, this is 6,000 PSI concrete, reduce the slab thickness, take, there's other things, not always, but sometimes that you can do that actually reduce overall carbon, right?
Building off that point, why are we looking at the per cubic yard carbon footprint and not the carbon footprint of the whole project?
An excellent point.
You could reduce the carbon footprint, for example, by using high strength concrete in certain places, so your columns could be smaller, or so you could have fewer columns and longer spans. Or you could use more pre-stressing and post-tensioning to make more efficient use of the concrete that you have. And your carbon footprint of the whole job could be much lower, even if the carbon footprint per cubic yard were higher.
Very true.
Even if you went back to just plain type 1-2 cement.
It is a wicked formula and has a ton of variables in it that we could exercise, and you're absolutely correct. One of those projects I put up there, 18,000 cubic yards, we could probably eliminate so much of the thickness of the walls, plus those structural members to reduce the total volume with higher cementitious and have a lower total GWP. I completely agree with you. Yep.
Yeah, so what's happening?
Yeah. Catch 22. It's so difficult to hit both. It's impossible. You can't. Yeah. It's good though.
Do we have any more questions?
Okay, I guess we'll try to bookend the process here. Yep. All right, so I think let's try to bookend the process here. I get questions on both ends here. First, maybe for Eric, do you think that a blended cement could be made to perform better than those same materials combined at a ready mix plant? Not through any fault of ready mix producers, but just from the fact that you have more process control over the manufacturing.
Yes, for sure. I think it's not an either or. I mean, there's certainly many levers available, and the cement, the blended cement is not the final concrete mix. I mean, there's a lot more that can be done by the ready mix producer. So the kind of constructing it as the question is as a choice between you do it at the cement plant or the concrete plant. That I think that's what we really need to move away from, and it's really both, and a good collaboration between the two cement and concrete, and how that needs to work. I think at a cement plant, you do have a lot more control. So we run AI through our process so our variability in our cement has never been lower because of AI. And so we can smooth out some of these variations. We can also take material that may be off spec and turn it into a material that's in spec. And so we can use a wider range of raw materials that expands the availability of the SCMs that can be utilized as grade in concrete. So there's a lot of levers there that we can do, but certainly not all final and done once we take that cement and take it to the next stage in concrete.
Thank you. I mean, to Colin's point, I think low carbon concrete is a goal, but I think another goal is better concrete. And so if we can make better concrete, then this should be an avenue we can explore.
And I think the key thing is, I mean, ultimately we need more SCMs, and introducing SCMs that have higher performance than and a wider sourcing of SCMs is something that the industry needs, and so it's not just about carbon. I mean, it's a small subset of people that care about carbon, but there's durability and having these access to broader range of cements that's important to a lot more.
To your point, regionally, the SCMs available are going to be very different.
Very true.
So over time, different contractors move around, then adapting to these changes more quickly is going to become even more important. Because as you go from one area of the country to another, as some of these more different SCMs become available, then you're going to have to adapt as you move around the country more quickly.
And at the tail end of the process, finishing and curing are maybe for Jim and Jim. Do you see more of these finisher certification requirements popping up in commercial specs and stronger curing requirements?
I've talked a lot. I completely agree, Eric. Yeah, absolutely. And in this region, there's a lot of certification programs that are available to finishers, and for the testing agencies as well, for curing of cylinders and the like. Absolutely, 100%.
But yeah, being on the producer side of things, you're on the contractor side of things. We don't see that lack of curing, and it's still out there. So tell me somebody in the room who hasn't recently witnessed a job that wasn't cured properly. That's probably everybody in the room.
Guilty as charged.
So yeah, it's still a huge issue because these mixtures are extremely sensitive to lack of curing. Extremely sensitive, and you don't do it initially, you don't do it right away. You're not getting back there.
When you guys are thinking about what he mentioned, that the SCM material consistency varies between suppliers, and sometimes it varies at different times from the same supplier. So do you all measure that to make sure that you're using, when you're forming a typical mix and you do all the tests, that's based on that particular source and that particular consistency?
100%. So luckily for us, we're local, so we don't have to venture too far. We go as far as maybe Richmond, so we have to be very careful. And the GGP we utilize comes straight from Connecticut. We have seen variations there, but we source it from one supplier because of exactly that. Our slags We source from one supplier. So that variation in that material, we know what that is. And it's very much locked in. And I've heard a great talk from Tyler about aggregate distribution and blending of the aggregates. For us, that is a huge component. We haven't even touched on that. From, performance of mixes, blending 8s with 57s is a game changer with the right stone. So, but we got to keep the variations minimized. Otherwise, we'll be chasing our tail, and it's dangerous. You're absolutely right.
And that's no different than changing from just one cement to
100%.
Yeah, so just to add to what Colin mentioned earlier about the specs issues, right? Data centers, great. They require GWP and all that, low carbon concrete, but we still see 4,000 non-air with 0.45, right? Very common.
Exactly.
That just pushes that powder. There's no way you can reduce the powder. The other issue along the same vein we have seen is in this area, right now we are about 60 high and 40 low, generally running, right? Daytime temperatures, right? And so the contractors are still not covering the structures, right? So when you want early age trends, and when you're not using maturity, if you're using maturity, that's great. But we're not using maturity, using fuel cured cylinders. And many times we are seeing is that you're not strictly placing the cylinders on the structure like what C31 wants, right? Because you just can't do that sometimes, right? You can't really place it really next to the structure. You're placing it far away, and you can imagine 60 to 40, the cylinder is seeing only 50 degrees, whereas the structure is well above 50 degrees, right? It's probably like 80, 90 degrees, even though it's not covered because it's got 1 inch thick slab or whatnot. But then you want 4,500 PSI in 3 days. And so now we have fly ash in our early strengths. Now we had to drop our fly ash because the cylinders were not making it, right? So we're sort of going the other way because of not being able to, practices have not quite matching what the goal is, right?
Unfortunately, we live that every day, Karthik, as you know. But yeah, it's a struggle.
Other questions or comments? Tyler, you've talked about in another setting the importance of maybe repeating some of these tests, not just when it first comes out of the mixer in the lab or out of the ready mix truck, but again and again, so you see the change of the properties over time.
Yeah, I think that's. I think we need data. We need a lot of data, and I think also if you test the concrete right out of the mixer, it's not going to be what's going to really happen on your job. You're going to haul it 30 minutes, 45 minutes. There's no reason you couldn't run these tests that I told you or other tests. Just wait, hold it 30, 45 minutes. You could do heated concrete, cooled concrete, but it gets more challenging. But we do it in our lab as well. It can be done. But I think all of these things we're talking about tonight, I think we just need to measure more about what matters. Not everything. But if there's something that matters to you, if plastic shrinkage is your big thing, if finishing is your big thing, if bleed's your big thing, get some data, share it with people, talk about it, learn some levers, talk about it with other people. We're in this together. Okay? We're not alone. We're not on islands. We're here to help each other. So that's what I'd say.
Here.
No single test on its own.
No.
It's taking a series of test data and looking at it and evaluating its set.
Totally agree.
Right. Anything you'd like to close with?
No, I mean, thank you to our speakers. I guess give one word that would sum up what's most important to adapting to change.
Embrace it. Embrace the change. It's okay. We'll get through it. Embrace the change.
Bring all your people in on the conversation.
I see. Concrete. How does it perform in concrete? Optimize in the concrete. You have many, many levers in the concrete.
Learn from other people and get data.
Thank you, guys. If everybody give them a hand.